Welcome to Abrar Electrical World. We have started this English series for the engineers who have migrated to Canada and USA, Australia, and basically North America, Canada. Majority of engineers are going there. So here I have today the how to select the power system voltage. Now the pictures are taken from various books or for teaching purpose only. Now this is a picture from the book I have taken from the book Electrical Machines, Drives and the Power System by Theodore Wilde. This is an American book. Here you can see a formula for the voltage. This formula we will discuss in other video. It is very important as well. But here E is equal to K under root PL. P is the power in kilowatt, L is the length in kilometer, and E is the voltage in kV. So this is the formula to calculate the voltage. Simple formula. Now let's see. The K is equal to zero point 0.1 and 0.06. K is equal to zero point 0.1 for uncompensated line, means there are no capacitor installed on the line. So we use zero point 0.1, and when there are capacitors to be installed, we can use 0.06. But I recommend that we should use zero point 0.1 because in case there are no capacitor or out of the line for some problem, then the voltage problem may occur on the transmission line. Now, when you get a value from this formula, it is recommended that get a range by multiplying by zero point 0.6 and 1.5, and you can select any voltage between that range. Now, this is another formula given, and from this formula I have calculated, we get this almost same values. So these are the two empirical formulas, and in practice, in American practice and practice all over the world as well. But these provide only a rough guideline. Actual selection will depend on various other factors, but this will give you and indicate the level. Now I have done here a sample calculation. E is equal to KPL under root. Now P 100 megawatt and L 100 kilometer. For the P I have written as 100,000 because we want here in kilowatt. So kilowatt here and then kilometer here, and I got 316 kV voltage. Now multiplying by zero point 0.6, the lowest one in the range is I got 189. So this factor will depend on your wisdom, that what are the distances, how do you feel about it, how much knowledge do you have. But this is not the end of the problem. Actually, you cannot select this voltage right away because you have to go the standardized voltage. So we will have to go to the higher side, that is 220 kV transmission voltage. Now, this voltage will also depend on the utility company requirement. So, suppose, for example, load is only 30 megawatt and you get here a voltage which is less than 100 or 100 kV. So, you will select the standard voltage as 132 or 145 kV. Now, you go to a electrical utility company where your substation will be connected. So, they will ask you to raise the voltage up to 220, maybe. Why? Because they are looking at the problem not in isolation. You are looking your problem in isolation. This formula is in isolation. It is not taking care of the whole of the system, whole of the network, the whole impedance, the power, the short circuit level, etc. So this formula does not take care of all those things. So utility company looks at the problem in the big picture, at the whole system, and the basis of the decision will be ultimately the load flow studies, power system stability, state stability, transient state stability, short circuit stability. So all those things will mm, ultimately control the voltage selection. A utility company may ask you whether you get 132 kV from the formula, may ask you to connect your station with the 220 kV because they have a bigger picture and they know that in future after 30-40 years this your station will be connected to other stations from additional lines, and in that case the short circuit level may rise and the load flow may also increase on the line which you are assuming. So this voltage may not be sufficient. So this is all from the point of view. This is my commentary that you have to look into the utility company, the local regulations, the right of way, etc. before selecting voltage. It's not only your load, your length of the line which governs the system voltage. This formula gives you only a rough indication. I hope you will like this If you like this, share it and subscribe it. We have started this channel for the engineers in Canada, North America, and we will be discussing here current transformer, protection, etc. from the North American perspective, their specifications, IEEE standard instead of IEC, ASA, CSA, Canadian Standard Association, and the Canadian Code CE, C, and the NEC, National Electric Code USA, etc. So I hope you like.